Hi guys, this is Mrs. Ullrey. In this video I'm going to talk to you about moles. So before we talk about moles, we need to realize that atoms are really teeny tiny. If we took just one single atom of carbon, it would only weigh 2 times 10 to the negative 23rd grams. So if we expand that out, that is 0.0 tons of zeros, 2 grams. So why is it that when we look at the periodic table, the mass that the periodic table reports is 12.011 grams? And the reason for that is because we don't, these masses on the periodic table don't reflect just one atom, they reflect a mole of atoms, okay? So if we take a look, a mole of atoms is a group of atoms of 6.02 times 10 to the 23rd. So instead of just looking at the mass of one atom of carbon, when we look at the periodic table, it's actually 6.02 times 10 to the 23rd atoms, to be exact. This number represents a mole. Therefore, the masses reported on the periodic table are called molar masses, the mass of 1 mole of atoms. So every single mass that's reported on the periodic table is actually the mass of 6.02 times 10 to the 23rd atoms of that substance. So a mole is a counting unit. It's abbreviated MOL, and its unit is used in chemistry that allows us to deal with numbers of atoms, molecules, ions, formula units in a sample substance. Just like a dozen is equal to 12 of something and a pair is equal to 2 of something, chemists have established that 1 mole is equal to 6.02 times 10 to the 23rd of something. In chemistry, that something refers to atoms or ions or molecules or formula units. Just like the number 3.14159 has a name, pi, 6.02 times 10 to the 23rd has a name, and that's called Avogadro's number, named after the guy who came up with this concept. So now, would you say a dozen pencils weighs the same as a dozen cars? Of course you wouldn't. So while the number of both objects is the same, right? A dozen pencils is 12 pencils, or a dozen cars are 12 cars. We would expect that their mass of these dozens would be different. The mass of a dozen cars is much bigger than the mass of a dozen pencils. A mole of anything represents the same amount of particles, that's 6.02 times 10 to the 23rd, but it does not represent the same mass for all substances. So the mole is linked between the number of particles and the grams of a substance. So the mass of 1 mole is equal to the molar mass of that substance. So if we take a look, gold, the number of particles, 6.02, is going to weigh 196.97. We get that from looking at the periodic table. Oxygen, 6.02 times 10 to the 23rd molecules of oxygen, weighs 32 grams. A mole of lead is going to be 6.02 times 10 to the 23rd atoms, but its mass is going to be 207.2. Silver, again, 6.02 times 10 to the 23rd atoms equals 1 mole, but the mass of that mole is 107 grams. Nitrogen gas, it's going to be 6.02 times 10 to the 23rd molecules, but its mass is going to be 28 grams. And then hydrogen, again, the number of molecules in the mole is going to be the same, 6.02 times 10 to the 23rd, but the mass is only going to be 2.02. We can use these numbers as conversion factors, and we write them as fractions. So one way we could write it is 6.02 times 10 to the 23rd particles is equal to 1 mole, or we can flip this ratio upside down and say 1 mole and 6.02 times 10 to the 23rd particles. We can also do this with mass. We know that 1 mole is equal to the molar mass on the periodic table. We can flip this the other way, put moles on top and grams on the bottom. The next video is going to actually show you how we use these factors to do calculations.